Welcome and thank you all for joining this Innovation Lunch webinar on the HoloLens 2. My name is Edwin Kombrink, Marketing Manager at Base Solutions and your host for this webinar. I do this session together with Wouter Martens. He is a Managing Partner and CTO at Mr. Watts. I think a lot of people heard something about mixed reality, smart glasses, and maybe even about the HoloLens. But don't know exactly what it is and wonder how it can be valuable to their own business. Well, to answer this question and to inspire companies with this innovative solutions, we organized this webinar together with our partner, Mr. Watts. Before we start, I would like to share some important announcements with you. This webinar will be recorded and shared in our after mail and on our websites. If you have any questions during the webinar, feel free to use the Q&A functionality at your screen. If there's any time left at the end of the session, we will try to answer your questions online. Otherwise, we will share the answers with you afterwards in a follow-up mail. Wouter, can you tell us something more about Mr. Watts and how smart glasses can be valuable for organizations? Ik denk dat je nog op mute staat, Wouter.
Yeah, I'm sorry. That went wrong. I was still muted. I think everyone can hear me now. So, like I said, thank you for the introduction, Edwin. I'm going to dive right in because there's a lot of content that we want to share with you today. And I have a small overview of what is coming up in this agenda. So first off, I will do a small introduction on Mr. Watts, our company, but really only 5 minutes. Then we'll highlight what smart glasses are in general. And then the main topic of today, of course, is the HoloLens, which of course is a smart glass. And we're going to do all the capabilities and show use cases of projects that have been done with HoloLens. And then last up, I will do a small roundup why we at Mr. Watts have chosen the HoloLens and why we focus specifically on that smart glass today. And then there's room for Q&A possibly. So let me go further. Mr. Watts. In fact, Mr. Watts is a new startup. It's a company which derived from iCaps. iCaps is a company that exists 10 years already, and we have been doing a lot of cool projects in mobile and web apps. We are a production house, so we build those applications for all of our clients, and they are in very different verticals. So we have a large customer base that goes from, in Belgium, Telenet to Proximus to, in Netherlands, bol.com, KLM, Philips even. Also a lot of banking applications that we are involved with. So we have a lot of experience. We have 10 years of experience in building enterprise applications. And now we decided to focus on smart glasses as a new segment, and there Mr. Watts comes in the picture. So we created a new company as a sister company of iCaps, and that's what Mr. Watts is. So the company was founded by Niels Leune and myself. Niels is also the founder of iCaps, and he is director of sales and marketing there. Me, myself, I am CTO of iCaps, and I'm also doing technology strategy and architecture for all of our projects. And we'll do the same for Mr. Watts. The vision we have for Mr. Watts is that we want to provide tailor-made mixed reality solutions for Microsoft HoloLens. And we want to do this to boost efficiency in your businesses. So we are really having a focus on business applications and not really entertainment, although we use mixed reality. For the people who are not familiar with mixed reality, I have listed a small definition here, which comes from Wikipedia, and they say mixed reality is a merging of real and virtual worlds to produce new environments and visualizations where physical and digital objects coexist and interact in real time. So this means that we bring digital context in the real world surrounding you. And you can interact with these objects, these holograms, if you want to call it like that, just like you do with real objects. So it is the blending of those two worlds together. We'll see video examples of this later on in the keynote. But this is what mixed reality is, and that is what we use for our business applications. Our mission is that we want to be a partner that can inspire you and blend this immersive technology in your ecosystem. And again, we want to improve efficiency or bring business value by doing this. So this means that we can be active through the complete life cycle of a digital application on the HoloLens, the mixed reality application, from inspiration to design to building of the application and to growing it afterwards. And we aim for being your long-term partner in complete this trajectory. All right, so that's it already for Mr. Watts. So you have in a nutshell, so you have a brief idea of what we want to do, what we're doing. And now let's focus on what smart glasses are. And again, I have a small definition here. So smart glasses are in fact wearable computer glasses that add digital information alongside to what the wearer sees. This is, you can call this like augmented reality. So we add digital information next to what the user sees. It's different than mixed reality because there we are really going to blend the digital content into the real world. This is more like adding information on top of what you see. So smart glasses is like a broader concept than mixed reality glasses, but it is where it all started. So we're starting with our story as well with smart glasses. And first off, I want to show you a couple of industry smart glasses that exist today and that are used in a lot of industries. And the most important one, or I think the most known, is RealWear. They are making these kind of smart glasses. You can see on screen that they not really look like glasses, but more like a headset that you can attach to a helmet, for example, or a cap. And they show a heads-up display in front of your eyes that can show information next to what you see. These glasses also have a camera to, well, look together with you, what you see, and then add extra information to that. There are a lot of other contenders or players in the market as well. Second place is Vuzit. It's also a big manufacturer of industry glasses, and they have the same models more or less. Also make glasses that actually look more like glasses, which you can see in the right corner below. This is a new model of them, in which they have a holographic display in one eye that can show information as well. And then number 3 and 4 are the Google Glass, because Google Glass is still not away. It has been around for a long time already, but nowadays Google applies it within enterprises. So it's actually called the Google Glass Enterprise, which you can see on the left side on the top. And there is also a Belgian company which is called Stick. Right side on the top, you can see Johan de Geiter, who is the CEO of Stick, and they are making smart glasses as well within Antwerp. So I thought that was worth mentioning, definitely. If we look at these smart glasses, what do they do? So most of them are powered by Android. The only smart glass that has iOS support today is, in fact, the Belgian one, Stick. All of the other ones are powered by Android. And they offer a heads-up display, like I said, or a holographic display. But typically, they only offer a very tiny field of view because it's a small display which is placed in front of your eye, and it's meant to help you in an additional way, not really in an immersive way. They have an ordinary camera, like I said, so no specialized cameras that more advanced smart glasses like the HoloLens have. I'll come back to that later. But they can use the camera for image capturing and also for computer vision, for example. They are controlled through voice control or a small touchpad on the side of the glasses, And optionally, they can be certified with water shock or explosion resistance certificates. So that means that they can be used in harsh environments, which might be interesting for industries. Prices for these glasses go from 1,100 to 2,800 euros. So they are kind of expensive if you look at what hardware they offer, but of course, in turn, they can offer a lot of functionality. At Mr. Watts, we consider the app functionality that we can offer through these glasses as rather limited due to the fact that the field of view is so small, so tiny, and that's not really supporting us for building true applications. So they are really meant to be used in a supporting way. The second type of smart glasses then is the mixed reality glasses. So here is my definition again. And these are a lot more advanced. At first, of course, we have the HoloLens, which you can see here. And you can see right up front that there are a lot more sensors in the HoloLens. We have not only one camera, but several cameras and also different types of cameras. A depth camera in the middle that I can show you later on in the presentation as well. So the HoloLens is, according to us, the most advanced smart glass, mixed reality smart glass available today. The details will follow in just a few minutes. There are, of course, more contenders than only the HoloLens. The second most important one is the Magic Leap. I presume a lot of you may have heard from this smart glass already, because it was, I think, the most hyped startup in Silicon Valley last year. They raised the highest amount of venture capital and built a nice product. It is in fact the closest contender to the HoloLens that is available today, and it's also working in the most, well, in the same way as the HoloLens does. In that it has the same hardware, more or less. It uses the same techniques that we will see in a minute. So it is a good competitor. Just a little bit more information, because we won't come back on this glass later on. But this headset is running Lumen OS. It's a proprietary, operating system that Magic Leap developed themselves. And they are building a complete ecosystem around this. So they have an app store, just like we have it on Android and iOS. There's also an app store for Lumen OS, where applications can be published. And the glasses are developed with a consumer-first approach. So they really want this to be like a device that we use in the future, just like a smartphone today, where you have an app store and you can download all kinds of applications that can be used for consumer use. Recently, though, they are pivoting towards more enterprise usage as well, since they seem to gain more traction there. And of course, this is also because of the ground that the HoloLens has covered in enterprise world already. Magic Leap is not blind for this, so they want to shift their focus towards enterprises as well. This headset is priced for $2,300. Sorry, so it's a little bit more expensive than the industry smart glasses, but of course it's also more advanced. And then a third mixed reality glass that I believe will possibly become big in the future as well is from Unreal. Not Unreal, the engine, but Unreal, I'm sorry. Unreal is a Chinese company, a Chinese startup, which is backed by Tencent, a really large Chinese telco. And they have a different approach. They build only the glasses, or they deliver glasses that you need to plug into your smartphone, like you can see here. And then your smartphone is the computing unit that drives everything. They only work Android-based, so sorry for the iPhone users, but the Unreal glasses are not compatible with iOS as of today, because they run what they call Nebula OS. It's also an Android operating system. In fact, it's an Android application that you install, and that does everything for the glasses. These, again, are developed consumer first. But Unreal is extending towards enterprises later this year as well. So we can see a trend there. And they announced this is the only picture that is available today. So it's a little bit dark on the right side, I know. But this is how it looks on their website. So currently they have the Unreal Light glasses, which are powered by an Android phone. And later on they will release an all-in-one model, which is aimed for enterprise and industry usage. That can be embedded inside a helmet again, presumably, because these are all rumors. The prices for these headsets, of course, the all-in-one model is not available today, so the price is not known as well, but the Unreal Light can be bought for 499 euros. So it's a little bit more cheap because you have to add your own smartphone to it. It does not come with a computing unit. So there you have a little bit of an overview of the glasses and the world of smart glasses today. But we are here, of course, for the HoloLens 2 and to show you what it can do. So I'm going to dive into that now. I am going to show a little clip at first that is an introduction video that Microsoft made itself or made themselves. It is about a minute long. Yeah, I'm just going to run it and talk over it. So I hope this comes through well, because for the rest of the presentation there are more videos. What we see here, oh, it's a little bit lagging at my computer. I hope it's okay for everyone else. So what we can see here is, of course, a production video where they show the HoloLens as a product, and it starts with hardware. These are things that I'm going to explain, not very in depth, but I'm going to explain them in a minute. But what is really interesting is that the second part of the video that we will see, that will start right now, is that we see what the HoloLens can do in a nutshell. There's a lot happening. We can see iris scanning already. We can see holograms floating around the wearer of the glasses. We can see holograms projected on the bicycle here. So you can really see that digital content is added to the real world. We can see multiple people joining the same experience and looking at the same mixed reality content, the same holograms. And that is all, I know it's fast, but hang on, we will go over each one of these items one by one later on. But all of this functionality is possible with the HoloLens from Microsoft. I need to mention that the current HoloLens available is HoloLens 2. So there is already a HoloLens 1 that exists for 4 years already. It entered the market in 2016. But the new version is a lot more powerful, a lot more capable, and has a lot of functionality, even hardware sensors and things that the first version didn't offer. And I have made a list of these things that are new or are worth mentioning. I'm not going to run over this list here, but this is what you may expect in the upcoming 20 to 25 minutes. So let's start with the display. The display is not really a display, it's a holographic visor. Microsoft does call it a MEMS laser display, but how does it work actually? Because we have seen the HoloLens, it looks like ski glasses, but you can see through everything. So how does it work? Well, in fact, the screen is not based off pixels like a normal screen is. In fact, Microsoft is projecting light onto the back of your eye. That's how they call it. And what you see here, this is a unit that is in the top section of the HoloLens glasses. And you can see that they use lasers, which are sending a light beam through a set of mirrors. And those mirrors diverge the light and make an image out of it. And then it bounces between really thin sheets of glass that are placed in front of your eyes. It bounces between these sheets, and then it breaks out at a certain point. And that point is just the point where your iris is. So in fact, they are projecting light onto the back of your eye, and that allows them to combine what you see around you, the normal world, because that's also light entering your eye, with digital images. One of the mirrors that they are using for this is the fast scan mirror, and I just thought this was nice to show you because this is a microscopic picture of that mirror. It's vibrating. Of course, this is enlarged and it is slowed down because this is vibrating at I think 60 Hertz, so that you get a fluent picture. But this is what is doing the magic and which is diverging the laser beam into an image that you can see. Anyway, what does it mean? That's more important. If we compare to the HoloLens 1, it used the same technique, but instead of lasers, they used LEDs. And because lasers are much more precise, now we can have a very large field of view that the HoloLens can use to project these images in. The HoloLens 1 had a diagonal field of view of about 30 degrees, which was the highest point of critique for the glasses because it was rather small for a mixed reality experience. And the problem that you had was that holograms or other mixed reality content was cut off on top, on the bottom, left, right, because the field of view was too small. Now you can see that they have increased it to 52 degrees diagonally, which is among the highest that can be offered today. In comparison to the Unreal Light and the Magic Leap, they also offer these diagonal field of views, but they are the only glasses. All the other industry smart glasses have tiny fields of view that go from 16 degrees to 28 at most. So it's really a big difference. And now the idea is that with every capability, I can also show you some use cases. So the first use case that I want to show related to this is one of ThyssenKrupp. I'm going to run the video right now. So what does it mean? What does this holographic display mean? Well, we will see here that in an industry environment or in a business environment, an operator that needs to repair an elevator, a ThyssenKrupp elevator, is going to use the HoloLens to see what his work schedule is and what the service log is that he needs for this elevator. And you can really see that he puts on the glasses and that all of the digital content that he needs is projected in front of him. Okay, here you can use a normal screen for, but he can see all the details of the components that need to be changed, that need to repair, and these can be projected on the actual elevator as well. So now he's going to start with his repair. And here he can bring the digital content next to the real content, what he sees, the real, well, print plate that he's looking at. What he can also do is he can use a remote assistance option in which an expert can look together with him at the problem and can identify and highlight in real time what components need to be changed. And that allows him to do the repair more efficiently, and he can capture everything that needs to go into the service log right away. So this, for the viewers that are paying good attention, you have seen that this example was using a HoloLens 1, not a HoloLens 2, but even the HoloLens 1 can offer you this functionality, although with a smaller field of view. But I thought that was a good example to show you how the holographic display can bring added value in your workflow. Next up is a new thing. This is something the HoloLens 1 didn't have, but HoloLens 2 does offer, and it's called iris recognition and eye tracking. So two things, of course. The first is iris recognition. Don't really need to put a lot of words in that. If you put on the HoloLens, it scans your irises and it can log you in with biometric security. It's a bit like a fingerprint on an iPhone or an Android phone. That's also biometric security. With the HoloLens, it scans your iris So that means that we can use applications in a very secure context, because this is much more secure than using passwords, also much more convenient and faster than using passwords. So it's worth mentioning definitely. And it also means that not only security is covered, but identification as well. The HoloLens knows who is wearing it because it identifies you based on your iris. This is something that needs a little bit more explanation because it is limited though. And one HoloLens device in an enterprise context can be used by up to 64 people at once. So it can remember 64 people, and it can remember the biometric data from these people on the device. So it's not stored inside of the cloud. It is kept on device to have everything secured. And the limit is 64 people. So that means that if you have a HoloLens on your work and several people are using it, that is the limit. If you go further than 64, you need to buy a second headset. But this is really interesting because as a developer, we can tap into the identification as well. And like with the previous example from ThyssenKrupp, we can have a personalized service log from the moment that you put on your headset, because we know who you are, so we can load your data. That is essentially what's important here. The second thing is that the HoloLens also tracks your eye movement. And this is a little bit of a weird image, but it's the actual footage that the HoloLens sees. So it looks weird because of the angles of the cameras. But the HoloLens, you can track your eye and can, well, see what you are looking at. And this is really handy as well and allows for specific use cases as well. Because an example use case that I wanted to show is one that is done by Heeft. And in fact, what they did is they simulated a shopping environment with virtual glasses. And there they tested which, in this case, coffee brands and which enclosures of the package looked best and caught the attention of the shoppers the fastest. So they were testing which packages worked best and which were looked the fastest at. And then they gathered all this data inside an overview, a dashboard that you can see on the right-hand side. But this was all tested in a virtual environment. So no real shop center needed to be created. No real packages need to be tested. So they implemented this in a smart glass solution and used the eye tracking that is also unlocked for third-party developers like Mr. Watts for usage. And I thought it was an interesting use case to show because we can tap into this functionality. The next capability of the HoloLens is what's called spatial mapping. And spatial mapping is a thing in which the HoloLens looks at the surroundings around you and creates in real time a 3D map out of it. So it uses this camera. It's like I said, in the center, in the middle. Up front, it's called a depth camera or a LiDAR. And it uses a time of flight technique. So in fact, what it does, it floods the room around you with lasers again. And based on how many of these lasers reflect back into the centers and how much time it took and how much weakened they are, based on all of this information and artificial intelligence, it can build a 3D map out of it. So you can envision this as a blanket of light that you throw through the room and that falls down on everything and creates a 3D map. There is an animation on that, so it looks, you can picture this or visualize it as something like this. So you flood the room and then you get this kind of wireframe out of it. But this is a really powerful capability because that allows the HoloLens to have holograms and digital content interact with the real world. Because if you put a hologram on the tabletop in front of you, in this case, it is a meeting room, it will really sit on the tabletop and if you push it off, it will fall on the ground. It cannot pass through through walls, for example. So it really interacts with the surroundings as we know it, as in the real world things behave. Shortly, I need to mention that this functionality is also improved a lot since the HoloLens 1, and that is mainly due to the fact because HoloLens 1 also offers this functionality. It also had the capability to build a spatial map. But the HoloLens 2 is much more accurate. And that is because of artificial intelligence, because the interpretation of the wireframe 3D model has improved vastly in the past years. So it's not really the hardware that makes the difference. Of course, they're using much more precise lasers and things like that. But it's mainly due to the artificial intelligence implementation behind that's making the 3D model. Again, a use case, or better, two use cases that I wanted to show you that make use of this functionality. The first one is a case by Microsoft itself, and it's called Microsoft Guides, a program in which they allow you to build a guided step-through tutorial using your computer and using the HoloLens. And so you build a tutorial. What you see here is it's done in again a factory context. So this woman needs to assemble an engine, and it's the first time she needs to do it. So she gets a HoloLens, and she will step by step be guided through the assembly process. And you can really see here that it's using the environment. It's pointing her towards the right materials. You can see that the indications, the arrows are fixed on the engine. We have animations, content that are also fixed and placed, projected right on the engine. So really a rich and immersive way to, well, learn how to assemble the engine here. And this is all possible because of the spatial mapping, because the HoloLens can see depth, can make a 3D model of the engine, and can place the markers, the arrows, and all of the other content right on that spatial map. So that is the first thing, first case that I wanted to show. A second use case is, of course, in the construction industry. This is, again, an example. The video is a little bit lagging. Okay, now it's running. This is an example in which a BIM model is projected using the HoloLens 1. So again, another example, but still relevant today. We can see construction workers discussing how an air vent system needs to be placed inside of a building. The video is a little bit lagging, so I hope it's, I don't know why it's doing with this video, but I hope you can see it. In fact, yeah, these air vents are placed on top of the building that is being constructed. So construction workers can really see where everything needs to go. It's highlighted in bright colors, and they can really discuss, okay, we need fixing points on these places. We need other power supplies, for example, on these places. So it gives a much more concrete visual of where things need to go inside of a building than a 2D plan. I don't know if this video came through well. If not, please let us know and we'll send it afterwards separately so you can have a look at it if you are interested. But this is something that the HoloLens can do because of its spatial mapping capabilities. Next up is hand tracking. The HoloLens is looking at everything. It's not only looking at your eyes and at the surroundings around you, it's also looking at your hands in real time, which is also a nice thing. Here we can see an internal testing tool from Microsoft where you can see that it can track both your hands at the same time and in real time. And the red gloves, so to say, are overlays of your real hand. So you can see that it is really performant, working in real time. And this is what the HoloLens uses for navigation and for making everything much more organic and natural than in the previous version. The previous version didn't have this real-time hand tracking. I'm going to rerun the video once more. The previous version didn't have this hand tracking, and there you had to use fixed gestures for selecting things, for moving through menus, for doing interaction with holograms. Now, as you will see in the upcoming use cases, it's not needed anymore. You can just grab a hologram like you do with a real object. You can tap on menu items, you can swipe through them. We also saw it in the introduction video of the HoloLens 2. And this is really a powerful thing, I think, because I tend to compare it with the iPhone. The iPhone wasn't the first smartphone. We had PDA devices before the iPhone came, but what Apple did, they made it feel organic and made it feel natural by using a capacitive touchscreen that allows to swipe, to scroll, to tap things, just like we are used to in the real world. And I see this for smart glasses as the same. Before now, those interactions were a little bit awkward still, but now they really feel natural. And that is a huge game changer for smart glass technology, according to me. And it's really precise because if you have a HoloLens 2, I encourage you to test out the Getting Started wizard with HoloLens. There you have this tiny little bird that you can interact with, and it really comes floating on top of your hand. And if you open your hand, it's well, it's not really landing on your hand, but it's really going to fly inside of your hand. If you close it, it moves away again, and it's nicely showing how accurate the HoloLens can track hands. Of course, the more important use cases are the industry ones. And here we can see an example from Airbus. They use the HoloLens for their engineers that are designing new aircraft. And you can really see here two engineers discussing a virtual part. So it's not been designed for real with real materials yet, but they are discussing it. And they are handing the components from one user to the other, all in a very natural way. Here they use it also for operators that are building airplanes. And here we can see someone who needs to assemble or attach a power-up cable inside of an airplane is also guided in his process. So it's using spatial mapping as well. But you saw the airplane he interacted with, you saw the menus, he just tapped on items like we are used to with touchscreens. Everything works like you expect it to work. And that is important with hand tracking. Another use case that I want to show you as well is one from Philips. They are working together with Microsoft to bring the HoloLens even into operation rooms with surgeons. And of course, this is only possible because you don't need anything else to control the HoloLens. You only need your hands, and you don't need special controllers or anything. And therefore, it can even be used for medical applications like you see here. And we have, again, multiple things the HoloLens is doing here, but with just your hand gestures, the surgeon can navigate through menus, can get real-time information about his patient during the operation. So I think this is a huge benefit, and it's only possible because of the accurate hand tracking the HoloLens is offering. Next to hand tracking, you can of course control the HoloLens also through voice control. So I'm not going to dive into details here. The only thing that I want to say is that since the HoloLens 2, the HoloLens is optimized for more precise voice control than before. They added 2 more microphones. You can see them on number 4 and 5. So they are really close to your mouth, and they have been tested in harsh environments. They should work in loud environments, in factory halls that are having machinery making noise. So very noisy environments, and even up to 90 dB of white noise isn't disturbing the ability of the HoloLens to capture your voice commands. It's using Cortana for this, so the built-in voice assistant in Microsoft Windows. And just to show you that Microsoft really paid attention to this, I have included this slide. They have what they call a silent room. It's a floating room at the Microsoft head centers. And there they tested the new microphones and also the HoloLens. They have a dummy that they can put the HoloLens on, and then they can play hours and hours of white noise and pink noise and any kind of noise and see whether voice commands are still captured correctly. And that's what they did. So next to hand tracking, you can also just talk to the HoloLens if you want to do things. But the other smart glasses, also the industry ones, offer this functionality as well. What is more important though is remote rendering. And remote rendering is something, of course, the HoloLens is a mobile device. It is untethered, so it's really a computer that you put on your head, and there is no wires attached, so you can use it in the complete world, even outside. But this means it also needs to be battery efficient, and it's using an ARM CPU, just like mobile phones today, for doing all of its computation work. Now, if we want to bring in really high-res 3D models as holograms and start to render those, then the HoloLens might run into its limits of computing power. And therefore, there is a solution. It's called remote rendering. In fact, what you do is you render these 3D models in high resolution on a computer or even in the cloud. And then I'm just going to run the upcoming animation already. Then it gets streamed in real time towards the HoloLens. So, of course, you do have a dependency for internet, and you need a fast internet connection to do this, but the HoloLens offers it through Wi-Fi or even 5G connection. So there is an additional USB-C modem you can attach on the HoloLens that offers 5G functionality that you can use for remote rendering. And for those who are technical, the HoloLens itself is capable of rendering 100,000 polygons itself offline on the device. If you want to go to much more higher resolution, polygon-wise, up to 100 million polygons, then you can use remote rendering. And Microsoft even offers a service in Azure for doing this. So you don't even need to do all of the technical heavy lifting yourself on your own machines if you don't want to. You can use the cloud for this. Okay, then shared experiences. So of course, an experience or an application shouldn't be limited to one individual solely. The HoloLens 1 had the capability as well already, but HoloLens 2 improves on it. They offer what Microsoft calls shared experiences. So you can share the coordinate system and everything else needed to have the mixed reality experience you need. And I'm going to show you another clip. So the HoloLenses can sync coordinate systems from one HoloLens to another, but they can also use the cloud environment again for doing this. And this is a promotional video that Microsoft has created to show you how it works. In fact, they are keeping a very big coordinate system, or I should say a composition of different coordinate systems on their cloud for your application. So you can identify a coordinate system for your app and say, okay, I want to store it in the cloud. And from then on, people can use it for entering a shared experience. They can use it not only from smart glasses, but can use it also from other devices like computers, iOS devices, Android devices, and have augmented reality experiences with those as well, entering the same coordinate systems. They are available across all of these devices and all of the users that need to enter a shared experience. It is important to mention also that these are not tied to one specific physical location. So, of course, it's very convenient if you are in one meeting room and you can have a shared experience looking at the same 3D model of a building, for example, that's sitting on the tabletop in the center of the meeting room. And then all of these users are co-located. But you can also bring in people that are remotely on the other side of the world, because the coordinate system can be shared across the globe as well. And the HoloLens is smart enough to combine this coordinate system with the spatial maps that these different HoloLenses are building and make an experience that works on both these physical environments. Because if I am here in Belgium and my colleague is in New York, of course, our surroundings are different, but because we have the availability of a spatial map, we can calculate the places there where holograms can be placed safely and that work for both of us. So an experience can be shared across different locations. And that is what the next video shows. So this is Spatial. It's an app for mixed reality collaboration, where you can see that people are looking at the same holograms, either in a co-located way when they are on the same physical place, or represented by a 3D avatar if they are on another place. And here we can see everything combined. We have two people with a HoloLens on the right-hand side. We have two other people that also have a HoloLens, but are in a different physical location on the other side of the world. They are represented by floating avatars. And then we have in the middle one lady who is following everything along through her laptop, and she is just represented by a video screen. So this is possible thanks to shared experiences in combination with spatial maps. The last use case I wanted to show for a shared experience is one by Natuzzi, because they use the HoloLens as a sales tool, basically. Natuzzi makes very nice but also expensive furniture, and they now deliver the option to really see how, for example, a couch looks like in your environment, and you can have different color options, different material options, and people are looking together to this hologram projected on the tabletop in front of them. So maybe a company you wouldn't mind using the HoloLens at first, but they are applying it as a sales tool. Then last up, something I just wanted to mention shortly as well is the Trimble XR10 for people that are active in the industry. This is a helmet that comes with the HoloLens 2 attached to it right away. So you can buy this as a product. It is available today, and then you can use the HoloLens inside construction sites or environments where safety is important. So just know that it exists today, and Microsoft had made a partnership with Trimble to offer this. Lastly, I wanted to show some more ordinary use cases, ordinary between quotes, things that are not using the advanced capabilities of the HoloLens, but are still really relevant and show that the HoloLens is just a new type of computer that allows new applications and new ways of workflows. The first one is Scandit. It is just using the normal camera for helping people find the correct orders. So this is an order picking application, and here you can see that the HoloLens looks along with the user, scans the barcodes on these boxes, and then highlights, okay, here are the Hillman wallboard anchors that you were searching for. It shows a picture or a 3D picture of a specific plug right next to the box. So it can help users find orders or specific materials more quickly. So not using anything special besides barcode scanning, but still relevant as a smart glass, I think. And then the last use case is one that we are working on ourselves currently with Mr. Watts. It's for gaming. And what we are doing is we are going to stream 3D video that is coming from one of the loading cranes that they may have right into the HoloLens, because we are aiming for controlling a loading crane from a distance, so remotely controlling the crane. And therefore, we of course need to have a good vision on what's happening in the surroundings of the crane. We need perspectives, so we are placing a 3D camera on top of the crane, and in real time, using low latency video streaming, stream those images to the HoloLens, and there we project a specific stereoscopic image. So different image for the left eye, another image for the right eye, and then we get depth sight and everything that we need for controlling the crane. So we have a real life perspective through the HoloLens. So not using any of the advanced capabilities, but these kind of things are also possible with the HoloLens, just like a VR glass, basically. Then, lastly, the roundup. Why do we focus with Mr. Watts on the HoloLens and not on the other smart glasses that were earlier in the presentation? Well, the first reason is that we consider the HoloLens as the most advanced hardware today. Like I said, the magic leap is a close second, but the hardware that the device offers is so much more advanced than all of the other smart glasses that are available today, that it allows us to do much more with this device. And like I said, completely new things of applications, new things of computing with the spatial mapping, with hand tracking, with iris recognition, all of that together. If we even combine it with our own artificial intelligence algorithms and computer vision, really powerful things are possible. We do believe that more smart glasses will enter the market in the upcoming years. There are very persistent rumors that Apple is working on their own smart glasses, so I have high expectations from their side as well. But today, the HoloLens 2 is clearly leading the pack, according to us. Also, the operating system, it is an industry-proven OS because HoloLens runs just Windows 10, the Universal Windows project. So Windows 10 is used by millions of devices across the world every day. It is battle-proven, it is stable. It's not like Lumen OS or Nebula OS from Magic Leap and Unreal. Those are new operating systems, which are by no means bad, but they haven't been able to prove themselves. So for enterprise applications, we want stability, we want an industry-proven operating system. Also, Microsoft not only delivered the hardware, they also delivered the mixed reality toolkit. That's where MRTK stands for. And this is, according to me, a solid software foundation. It is lowering the barrier for building really rich applications a lot with, like I said, all of the gestures that are available, the hand tracking, the advanced hand tracking, all of the things that this software development kit offers. Is really powerful and is out of the league compared to other contenders. Then there is the Azure ecosystem, things like remote rendering, Microsoft Cognitive Services. All of these things can be hooked onto other smart glasses as well, of course, but the integration between the HoloLens and Azure is much more easy. So it's also really powerful to combine those two together. And maybe even most importantly, the HoloLens is developed with a business-first mindset. And it's the only smart glass that was developed this way. All the others were developed consumer-first and are now pivoting, like Magic Leap, like Unreal. But this is the only mixed reality smart glass that was developed business-first. The industry smart glasses, of course, are also developed business-first. And it is backed by Microsoft. It's one of the big tech giants. So we expect stability. We expect that the HoloLens is not going to go away. Microsoft has invested a lot of time and money in this project and really believes in it as well, just as we do with Mr. Watts. So again, stability, which is important for us. This is more or less what I wanted to share with you guys today. So if there are any more questions, you can type them in the chat. I'm going to see, because I think a couple of questions were maybe missed. There is also a small delay on what I am talking about here and what you are seeing. I think more or less 30 seconds even. So if you have any more questions, please send them to us in the chat and I will answer them towards all of the viewers. In the meantime, I'm going to inform you about two small things. The first one is if you are inspired now and want to have your own little workshop on ideation, then there is a HoloLens value canvas that that Mr. Watts, sorry, has developed. And it is a free download on our website. So we can use this more or less like a business model canvas to well, put all of your thoughts into a more structured overview and see whether smart glass technology, HoloLens technology might be beneficial for your use cases. Like I said, if you go to our website, mrwatts.io, you can download it for free, and there is even a manual that comes with the canvas, so you know how to use it. So that's one thing. Secondly, for now, in a brief, in the upcoming weeks, we at Mr. Watts are offering a free ideation workshop. So if you are inspired and you want to think along together with us to see whether the HoloLens or the smart glass technology in general can be beneficial for you, we can do a free ideation workshop. Again, you can go to our website for, well, applying for this, and then we will get in touch with you. There is a dedicated URL, mrwatts.io/ideation workshop, or you can scan the QR code. But I think even roundabout now, we will place a link on our homepage. So if you just go to mrwatts.io, you will get all the information you need. And then let me see. This is the last slide. So let me see if there are more questions or not.
Wouter, maybe there's one question to cover.
There is one question. Does it also allow to take measurements of the room?
Yeah,
good question. So this, I don't know who asked the question, but there's a question about the spatial map. It is indeed taking the measurements of the room because it's building a real size 3D model. And this 3D model is accessible by us as developers as well. So we can do distance calculations, any type of calculations that you can do on a normal 3D model can be done on the spatial map as well. So we are aware of measurements and sizes of the room, yes. Let's see if there are even more questions. Okay. I think this is more or less it. I don't see more questions popping in directly. So I presume everything was quite clear that I said, which is nice. So if you still have more questions, please. There is just coming in one more. What are the standards that the data can be shared in with other applications? So a question by Rick. So I think, Rick, that you are referring to the 3D model data, because in fact the HoloLens can be combined with any industry standard for sharing data. So if you capture 3D data, for example, we can get it out, the spatial map as an example, for example, like an FDX model or DAE model. So it can be converted into different 3D models. That is for 3D data. Other kinds of data can be shared in any type of information, like XML or JSON if it needs to be structured, or just plain text logging if that's required. If you want, for example, the iris recognition data or the time of flight depth information, that can be translated into several data carriers, if I can call it like that. So that is an implementation that we can do at Mr. Watt's site, and that we can unlock the data in the format that your ecosystem needs. That is also what is in our mission, of course, that we integrate this immersive technology into what works for you. So we can help you out with that.
Wouter, I see one last question, then it's time to wrap up, I think. Can we cover the last one from Babs?
I can see Edwin is talking now again, but he is still muted, I presume. Okay, the secure. I see an additional side question on the one from Rick. He asks, what about the secure login input, for instance? Well, how the secure login works is that, of course, that the biometric data resides on the device itself. So that is the one part of data that is not fully accessible for us as third-party developers. So what we can do is we can use system APIs that the HoloLens offer to log a user in an application, for example, or know who a user is. But it is all encapsulated on the device, and even in a hardware encryption chip. It's called the TPM module. It's also in laptops nowadays. The HoloLens uses the same technique, so we can interrogate these APIs and this functionality on the operating system, but we cannot manipulate it. We can ask whether a user is logged in and give an access token towards a server or an API from within our application, but we cannot really access the data itself. I hope this answers your question. So if you want to build on top of that functionality, you can incorporate, well, the right API calls inside of your application, and when it runs on the HoloLens, we can log users in automatically. It's a little bit the same as with Touch ID on iOS, or a fingerprint on Android, fingerprint recognizing on Android. That can be used, for example, inside a banking application as well. The same goes for HoloLens apps and with iris scanning.
Wouter, there is one question.
Okay, Rick says it's clear for him. I'm glad. Thank you, Rick. Let's see. So there is also someone, Babs, who is asking about remote auditing. And she says, I am interested in a solution to do remote auditing. So the info should be transferred easily from classes to a computer system. As eventually real-time communication is important, I believe more functions can be added, but first the basics should be right. Is there an option? Maybe this is an ordinary case. Well, the HoloLens is a connected device, Babs. So in that, with connected, I mean it has Wi-Fi and 4G or 5G optionally on board. And with that regards, it doesn't differ from a normal laptop or a smartphone. If we need to push data in real time towards the HoloLens, that can be done. And that can be done by using traditional web techniques like a chatting technique. If you do a chatting application like WhatsApp or Slack or Facebook Messenger, then it's a little bit technical, but a technology that's called WebSockets are used. It's a real-time communication protocol between a device and a server, and that can be used for chat, which needs to be real-time, but it can also be used for any other types of data. And that is something that we combine with the HoloLens perfectly as well. So It's again an implementation thing. It depends on how we build the application. It's not limited or foreseen out of the box by the HoloLens. So that is what we at Mr. Watts again can help you with. And that works in both directions. So from a computer towards the glasses and from the glasses towards the computer. So that can be done, yes. I hope it answers your question. Let me see if there are any more coming in. Because I think most of them are answered. I don't see any ones that I didn't tackle yet. Okay, so then I presume we round up. I hope it was very interesting for you and that you learned something today. If you are interested, contact us and then we can talk further. Thank you for your attention.
Thank you, Wouter, for your inspirational session and your details about the smart glasses.